So there is no as such mapper and reducer phase over here, and that's make it faster than MapReduce. So all your data is there in the memory, and you start once you read the data into memory, you have to just apply the logic which you want to apply up, and as the data is already lying in memory, you can think of how fast processing could have happened. could happen. So the beauty about the Spark is it tries to process all your data in memory. First, it gets your data in memory, and then it tries to process all your data in memory. Until unless there are phases which really require your data to be shuffled up and sent across node, it do not shuffle your data or send it across the nodes. So if you have to create some data flow, practically I have to create the chains like this. And at all the phases, you can think of how much input and IOs happen on the disk from mapper side and onto the reducer side, and that makes the whole process extremely slow. So if I have to learn some machine learning algorithms on MapReduce, that will be a very slow task because machine learning requires a lot of running the same algorithm again and again on the data set to figure out some particular values or figure out or do analysis on the data kind of thing. So
Just to double check, Raj, we are not seeing anything on this screen.
is it? But my screen sharing is there. Is no one able to see my screen?
I'm able to see it.
Yeah, I can see. Right now you are sharing the MapReduce one.
Yeah.
So I think Kamalji problem at your end.
Okay. All right. I would just connect back.
Okay. So there's a lot of IOs happen at all the phases, and that makes it very slow. So what Spark does is, so same flow can be implemented in Spark. Let's say that there is some process which we are running up, or some, let's say we are running up some machine learning algorithm which requires to pre-process same data again and again to figure out some analysis on the data. The same thing could be done in Spark, wherein we just read the data once, put it in memory, and we just apply all the phases of the algorithm in memory and output the data, final data to the disk. So you can think of how much IOs are saved in the whole process, and that makes this guy extremely fast. The data is, all the data cannot be always be basically fit into the memory. So they are that could be scaled up, but the data which could be stored in memory, that data is stored up. So there are a lot of ways it stores data in memory. It could be in memory, and it could be in memory and disk. It could be all disk. So it's all up to you how to define the algorithm, how to store basically the algorithm which need to be used up to store the data. But the power comes up if you have good RAM, and you are able to store your maximum amount of data in the RAM and start processing that data. So yeah, it definitely requires a lot of RAM to keep your data in memory. So as I told you, it's up to you to choose any choose whether you want to use Spark or MapReduce or Tej as the engines to process your data. It will definitely be dependent of a lot of factors. So what are you trying to achieve? What is your priority? What is your system limitations and all those things? So you have to choose the corresponding engine to process your data. But each of the engine has their own advantages and disadvantages. I have 2-3 slides which are comparing MapReduce and Spark. At the end of the session, I'll show you them also. So, but it's up to you to decide what need to be used up. Definitely both will do the work for you. So it's an open source. It supports writing your programs in Java, Scala, Python, and the key construct over here is resilient distributed datasets. So we'll look into what exactly is resilient distributed datasets, RDDs, and that's all make Spark powerful. So they divide your data into RDDs. It's similar to your splits, almost similar to splits, and that divided data, again over here the same thing, divide and rule, so that so all your logic is applied onto your divided data, and till the time data merging is not required, and if the data merging is required, then your data transfers over the network onto the other nodes where the merging happens up, and that data is again cached into that node memory where the data has been transferred to. So what happens up is, so we have a driver program that drives everything in the cluster for a Spark program. Cluster manager gives you the resources. There are worker nodes which do the real work for you. So it's similar to the MapReduce. The data would be lying on some node into your blocks. So wherever data is lying up, is the worker node is practically created over there, and you pick the data onto the corresponding node and start processing that data in memory till the time you do some operation which really requires the data transfer over these nodes. Now, if the data transfer over these nodes is not required, let's say I'm running some filter operation kind of thing, or I am running some count operation kind of thing. So on those operations, I practically do not require data to be transferred over the networks. Let's say I'm running some join operation kind of thing. In such a scenario, data transfer will happen over the network, but in the operations like filter or count, there's no need to transfer the data over the network. So the worker nodes do the real work for you, and this driver program manages the worker nodes and it assigns the tasks to them. And these tasks, individual tasks, run on the worker nodes on the data which is lying on the worker node. So the data is loaded into the memory of the worker node, and these tasks are applied on that data which has been cached into their memory.
If we are connecting multiple HDFS files and one file is on worker node 1 and second is on worker node 2, which means that would increase the IO?
IO तो होगा ही, एक बार तो डेटा पढ़ना ही पड़ेगा चाहे स्पार्क हो चाहे मैपरेड्यूस हो. Once your
But
data
over the different data nodes, which is same as worker node, is my explanation is correct that it would be a hit to the performance in such cases?
So if I repeat your question, you are saying there is a file which is lying, the first file is lying over here and second file is lying over here. Will that increase IO?
That's right.
So that's what I'm saying. IO will always happen because I have to read the file. Even if both the files were lying over here, I would have to read them. Reading those files will definitely require some amount of IO, and that would be same even if the file was lying on the same node or the file was lying on the different nodes. पहली बार तो मुझे पढ़ना ही पड़ेगा डेटा को.
पहली बार पढ़ना पड़ेगा. उसके बाद there is an action after reading the file, and that action has to be performed if the file is across multiple data nodes. Then the worker nodes would be accessing. Now taking it to a common data node for the execution or the cache purpose.
So it is not transferred over to a common data node. That's what I'm saying. So your data, which is again, it's the same concept of split applies over here also. Similar to that, not exactly same. So the amount of data which is lying on this data node will be processed on that data node. The amount of data which is lying on the other data node will be processed on the other data node till the time there's a requirement or kind of action which I'm applying up on the data which requires a transfer over the network. So till the time
Okay.
I do not trigger some action which requires joining of these data sets, the data is processed there on the local nodes. So this guy requires the full network connectivity to the workers so that it can manage the workers and assign the task to them, which it decides based on the action which you have triggered up on your data. So we just looked at drivers. So driver is responsible for converting your user program into units of physical execution called tasks. So let's say you have defined some big program which contains 1, 2, 3, 4 steps. So that divides these steps into small tasks. How it divides, I'll tell you in few minutes. So it divides those programs into small units of tasks, and those tasks are given to your worker nodes, and they run up those small tasks one by one the way the way worker nodes are told to run the task. Driver coordinates the individual task on executors, and driver will look into the current set of executors and try to schedule each task on appropriate location based on the data placement. So जहाँ पे data पड़ा होगा, it will try to place give the task to the corresponding worker node based on where the data is lying up. So each executor represents a process capable of running tasks and storing RDD data. So RDD is similar to your split. So the data is divided into blocks, and that blocks would be lying on some data node, and the block which is lying on a corresponding data node, that task is run over there on that block. So this is RDD1. So that is called resident distributed data set. So RDD which is lying, so data which is lying practically on the data node is processed over there. So each of the data which is lying on the data node is practically called RDD if I talk in layman terms. Spark acquire executors on the nodes in the cluster with the help of cluster manager. So cluster manager like Yarn or Mesos. In AWS it's Mesos, and in Hadoop it's Yarn. So cluster manager gives the cluster, that is the resources, to Spark program, and the resources are given once the resources are given to the Spark program, it runs your executors on the corresponding nodes. So similar to what we did, what we looked at the Yarn architecture for Hadoop, similarly over here also you get your resources with the help of Yarn. So resource manager will do that, all that now, because resource manager is the guy who manages resources in the Yarn. So with the help of resource manager, it will also get the resources for where to run up the executors, and it will try to run up your executors on the nodes and do all the similar things. So each application gets its own executor processes which stay up for the duration of the whole application and run the task in multiple threads. So एक बार मैंने कोई application trigger करी, so you get your executors on the corresponding worker nodes initiated, and once the executors are initiated, they remain live for the whole life cycle of the application, and the tasks are being calculated from the driver program, and tasks are assigned to these executors. Executors run those tasks in the order they are assigned the task, and these tasks could run in multi-threaded environment also. Make sense to everyone? Any questions? So practically there is no phase of map and reduce kind of over here. All the processing is divided into small tasks, and the tasks practically run on the executed nodes which do the real working for you. And there's one manager called driver program which manages all the processing across the cluster for you. So as I told you, you can write a program in Java, Scala, Python. We'll look at Scala. So we have interactor for Scala and Python. Yesterday we started interactor for Scala. Similarly, there's another shell in the bin for Python also. You can run that if you want to play with Python. Standalone applications, you can write in Scala, Python, or Java, anything. And Scala is said to be the fastest for Spark. But there's no significant difference between Scala and Java practically. Yeah, but definitely writing a code in Scala would be much easier if you understand Scala, and that would reduce your lines of code uh, extremely less.
So, Miraj, one question, because we had something similar which we were working on for one of the things. When we compare such languages, like right now we are comparing Python and Scala. So how we could say that Scala is faster than Python? I mean, what are the criterias there? On what basis it is determined? Because a language is just a language, right? That could be other things which might impact the
Uh,
speed.
so over here, it's speed based on the Spark. So Spark has to process. So at the back end, the whatsoever logic you have written, that logic need to be divided into the task, and on the task, that logic with the help of task, that logic need to be ran up in the corresponding executors. So the compiler and other things which are required for Python are slower as compared to Scala and Java. So that's what has been highlighted over here. So interpreter
Okay,
which
so
interprets that what has been written into XYZ language. So there are three
oh,
interpreters practically running up in the driver program to understand the things. Something could have been written in
mhm.
Scala or Java or Python. So based on the interpreter and the corresponding interpretation, that's what we are talking about.
Okay, got it, got it. This was very helpful because that's what I was wondering. Uh, we were doing some analysis. We are comparing, various things and that's what I
But
was wondering.
again,
Thank
there
you for
could be
that.
different things also based on, let's say, you can read extremely fast in C with the help of pointers, which exactly point your corresponding bits and bytes into the file. But
Mhm.
in Java, that is not possible. So again, based on the different languages, there would be different advantages for different things. But over here, what I'm talking about is this.
Yep, that makes sense. In this context, it makes sense.
So there are a lot of things in Spark. Will not be covering up all the things, but there's a lot of things to learn up in Spark. So there's Spark SQL also, which helps you to write a SQL kind of thing and run the Spark programs, but it's not exactly a SQL. You have to write some Scala code and give the SQL over there. Spark streaming, you can stream your data coming from live streams and process the data. MLab, machine learning algorithms, there are a lot of machine learning algorithms available in Spark Lib, and you can run them. GraphX for creating your basically edges and vertexes, or basically you create your graph on your data so that you can figure out relationships in the data. So there's a lot of things which are available in Spark library. Spark itself is a big program around 25 to 30 hours, so we can't cover all the things, but we'll just look at the basics of Spark and Spark streaming. So similarly, I told you similar slide I had in MapReduce Word, where we started up on the first slide. So that has 1 TB sort benchmark. Similar kind of benchmark is over here. Yeah, Scala is all written in Java only, and just try to listen some videos of Scala. You'll be able to understand it easily. There's a funny guy video which are very much common over YouTube for Scala. That's an Indian funny guy. If you Google up, I think on YouTube, if you just write Indian funny guy or something like that for Scala, you will find out some of the videos for Scala. Those will be sufficient for you to start up the basics of Scala. So this is a benchmark again for Spark, which was recorded up, and this is the kind of speed difference which people were able to get up in between Spark and MapReduce, and sort rate on the nodes was this. So number of nodes who used over here was 2000. Here it was 206. So sort rate practically which we got on MapReduce was 0.67 GB per minute. Here we get 20 GB per minute. So this was tested on 100 TB of the data, 1 trillion records approximately.
Coming back to the previous slide, in these scenarios, the number of nodes which was referred were low from Hadoop MR. Is that one of the reason why the Spark performance is so high?
No, over here you can see the sort rate per node is 20 GB. Here we were able to achieve only half a GB per minute.
Okay, what is number of nodes signified over there?
The cluster size.
Cluster size. Okay.
But practically the codes in this cluster was 6,592. It was 50,400. So definitely if the nodes were less, the CPUs would also have been less.
Okay.
Okay, so everything over here is divided into resilient distributed data sets. Resilient means able to reconcile or spring back into the shape after being bending, stretched, or being compressed. So anything, so resilient is something like an elastic. You play with it and you can again reconcile it back. So your data is basically divided up. It's almost similar to your data blocks or the input splits which we looked at. So your data is played up on the corresponding data node, so it's lying up. Till the time it's not required to merge the data on with some other data node. So these are immutable distributed collection of objects, splits into multiple partitions which may be computed on different nodes. So RDDs can be created in only two ways, either from Hadoop input formats, or you can use parallelize as a feature available for you, which parallelize the data and it creates RDD for you. So yesterday we used parallelize. I told you, no, rather than reading a file, I'll just create a RDD. So I use the parallelize as a function to create RDD, or you can create RDDs with the help of Hadoop input formats, such as SDBus files. So it's all an lazy evaluation. So till the time there is no action which has been triggered on a program, the processing really do not start up. So similar to pick program, if you remember, I created a lot of statements. Till that time I do not trigger a command called store or dump. Practically there was nothing happened. So similarly over here, there's a lazy evaluation. So till the time you do not do something which is called an action, which requires an action, your real data processing does not start up. And actions can be applied to RDDs only. Actions for the calculations and return values. So I'll tell you what functions are exactly in operations and what are not. So what happens up exactly is, let's say, so this is a Scala program which we're looking at. So let's say there's a cluster which have one driver node, three worker nodes. I write a Scala line on the console which I was showing you yesterday. That is the Scala interpreter for Spark. So let's say I written a line where log sc.test. Sc is a Spark context which is already available uh, on the interpreter. So when the interpreter starts up, the structure रहा है क्या? So So Spark context is available as SC. So Spark context is the way to interact with the Spark driver program practically. So that is already available in the shell with the variable SC. So we are using the same Spark context. Dot text file is to read a text file, and I'm giving a file path in HDFS. So this will try to read the file for me. Then I says I want to filter this file and filter the lines which contains a keyword called error. So here underscore, so this is a little intelligent language. Here dot underscore dot means, so this is a lambda function which has been called over here. I'll explain what exactly is a lambda in few minutes in the next few slides. So here practically what is happening up is this filter is applied on each and every line of this file, and it's trying to filter the lines which contains a keyword called error. Then I say errors or cache. So this filtered errors, I'm trying to cache it into memory, and I can perform n number of operations now on this error because this would be available as a processed cache in my worker nodes. Now I say errors dot filter which contains IO error. So input output operations के जो error आए थे, I just want those errors and I just want their count. So this is an action because I said count. I want something out of my program. So this will trigger an action. When an action is triggered, so till now it was all lazy evaluation. Nothing has happened. Even if I call errors.cache, there's nothing happened on the cluster. Once I say some action on my cluster, at that time something happens in my cluster. So count is a kind of action. So now driver will try. So these are the blocks of your files which are lying on the worker nodes. So driver will interact with the worker nodes. Worker nodes will do the processing for you and return the result, that is the count which has been summed on the driver and returned to you. And now your data will be cached up on your worker nodes. So if I call any other action on this cached errors, next time there will not be any IOs on the corresponding nodes. I would just be reading the data which has been cached up on the corresponding worker nodes and will delete that. So let's say I called something else, errors.filter contains timeout. So I want to count the time errors which are timeout errors. So in such a scenario, driver, this is again an action because I'm doing count. So now driver will again interact with my worker nodes, and there will be no IO which would be done now. It's everything is cached up in the memory of the worker nodes. So worker nodes will just process that cache data and will return the output to the driver. Make sense? Make sense to everyone? Okay, I assume it makes sense to everyone. So what happened at the dataset level? This is the file on which we wanted to on which we practically created an errors RDD. So this RDD was filtered on the file. So what happens up is the blocks which are lying on the data node, this filtering happens on those blocks. So at this time there is no transfer over the network which is really required up for to filter the data on the corresponding block. We practically do not require any data transfer over the network, right? So this is your task. The task would be created up in such a mesh fashion that whatsoever can happen on a single data node, that should happen on a single data node in a one task. So let's say these are the 4 blocks for your file. So your task will be given to the corresponding executors on the blocks, and that will run up and do the filtering for you. Is it making sense to everyone, or yes, no? Okay, I'll assume it's making sense to you. So you can see over here what I did is, this was an RDD, this was another RDD, and I am applying some functions on RDD, which has been returned as the errors name. So this RDD will be partitioned across different data nodes. So these are the blocks which are associated to this RDD. And later on that RDD is logs RDD, and that logs RDD give me an error RDD, and these were the blocks which or partitions which are associated to that RDD. So tasks are assigned to your partitions which are associated to your RDD. So you can see each task is being given to a partition to the corresponding RDD.
So how does this framework works? Is this partition is being done by us, or this is based on data and this is a smart partition by Spark?
Based on data. Based on data where the data is lying up.
And do we have to do anything, or Spark automatically take care from the master nodes and define the partition?
Yeah, you don't have to do anything. You have to just write 3 lines of code which I did up. It created the partitions based on the blocks which are available on the data nodes.
Okay. So internally, if to understand the concept, Spark is talking with master nodes, finding out where is the data lies. That's the exact area, and a partition is being created, and worker nodes is being assigned to take the further actions needed.
Yeah, worker nodes are given tasks which are which basically runs on the partition. So the terminology changes over here. Majorly it's the terminology which changes over here, but internal concepts much remain same. There is no map and reduce phase over here. You divide your whole work into tasks, small tasks, and tasks are practically the division of your work, and the boundary of a task is such that so let's say I've defined step 1. So I have step 1, 2, 3, 4, 5. So if I have defined some other thing on the errors, let's say I filtered it further on, and then I cache the errors 1. So I've created another variable called errors 1 that was filtered on something else, and then I created errors 1. So whole task would have been all these 3, 4 steps, because this could have happened on a single node. Connection lost. Connection lost. क्या हो गया? Are you people? Can you hear me now?
Yeah.
Yeah,
Yes.
Okay. So I don't know what happened. I brought a new router. I don't know. Okay, all the range is good, but I didn't know this will happen with that. Okay. Okay. So all of these are practically RDDs. All of these things are called RDD over here, and that is a resilient distributed data set. And the data set is practically partitioned across your data nodes, and you run tasks on those partitions which represent a data RDD. So over here, this is a file, and this is another RDD practically. So your task is practically running on two RDDs. So task endpoints can be running on n number of RDDs based till the time it do not require some shuffling of data across the nodes. So if there would have been one more filter operation, this task boundary would have been increased to till that filter operation. So single partition have processed on single node. Single node can handle multiple partitions based on the CPU and another thing available for you. So let's say these are two data sets which I want to join and do some operation on that. So I'm doing group by and then filter on them. So this is how your scheduler will do. So in the first phase, as the joining is required, so this data set is, let's say, partitioned into two partitions. This is partitioned into two partitions again. When I have to join them, practically there will be a lot of shuffling which will happen across the network, and that data need to be transferred over the network to do the joining on them. And the filter can happen there only where the data is lying up. So practically you interact with your cluster manager in such a scenario to get the resources or where to run the executors. And the workers really run the task for you, and task boundaries would be practically something like this. So what we did is we did a join and then we did some filtering, let's say. So over here, task boundaries will be in such a scenario that till the time there is no shuffling which is required or data transfer which is required across the node, task will run on the partition. So this is how the task boundaries will be defined up and given to the corresponding nodes. And that's how it's much faster as compared to MapReduce. So data is processed there only where it's lying up. There's no short and shuffle page which does a lot of IOs for you. You divide your program into tasks, and tasks run on the partitions which is lying on the corresponding node, and partition and the task boundaries are such that till the time you do not really require some shuffling of data across the nodes, your tasks run on the corresponding partition of the RDD.
Miraj, in this case, I assume if we want uh, the better performance, I think we'll have to plan our tasks such that, we get, I mean, whatever code we write, we get the optimum, I mean, it should be optimum so that the result will be like, for example, in CDF, if in C there is mix of all data and then I needed some particular data. So I will say kind of filter it and send it to D so that in D using that and the current data, it will find something and process and
So
give
it's
the
not
result something.
so it's not sending, it's happening on the same node. So this task is happening running, one task runs on one executor practically.
ओके तो अभी जो लास्ट वाला एग्जांपल अपन देख रहे थे इसके पहले हाँ अभी इसमें basically I understand that we got log then we tried to find what is error in that and then we tried to find the cache of it. So this I assume are the three different tasks. I mean this is this three will make one task, right?
Yeah, these three will make one task because they do not require any shuffling of data across the
Yes.
network.
Yes. तो अभी अगर अपन वो जो अभी आप डायग्राम बता रहे थे तो वो C D and E हाँ तो सी डी एंड एफ तो इसमें कैन वी सेफली से इट इज स्प्रेड अक्रॉस सी डी एफ और इट इज जस्ट ऑन सी
Yes. So acha, if you talk about in terms of nodes, so this is your one single node, let's say. So this thing happen on the same node, and this partition. So this is your one node, let's say data one. This is your another node, data two. So this will happen on that data node. This will happen on that data node.
ओके तो अपना अभी जो हुआ था वो डेटा नोड वन पे ही हुआ था तीनों का तीनों
CDF ran on one data node. Again, the next CDF ran on another data node.
Yeah, correct. So I mean, considering the same example, error log wala, I can say that it is only running on D1, right?
So this this CDF running over here, another CDF running over here, and third CDF running over here.
And these three are three different data nodes.
Yeah, so partitions, practically three partitions for this RDD.
Okay, and okay. I got you.
Then this returns some RDD, and let's say this RDD is lying on. Then this returns another RDD which is lying on these three nodes. So then this error dot filter will run on the corresponding RDDs of these partitions. Sorry, partitions of these RDD.
Okay. अरे पार्टीशन फिजिकल पार्टीशन होता है ना
Depends. So this was physical partition, then this was all your data which is lying up in the RAM. Over here, so this data was sorted, transferred over the network. So now this is all in memory. This would also be all in memory, and this output will be all in memory also practically. So I told you the task boundaries are always in such a manner that till the time you don't require something which requires transfer over the network, that's what create your task boundaries. And if anything fails and the task is reassigned and re-given to the corresponding nodes and all those things. Similar things happens over here also. So even if they are failures, that those are being taken care. So all of this thing happens internally. You don't be you will not be seeing all these things, but this is how internally happens up, which I wanted you people to tell to know, basically understand how internally happens up it and how basically your Spark is faster as compared to MapReduce. So there are two things: transformation and actions. So these are just a transformation on the data. Again, a transformation on the data. Till the time I do not trigger an action, these were all transformations. So till the time I do not trigger an action, nothing happens. Everything is lazily evaluated. So there are two things in over here. One is called transformation, one is called action. And till the time action is not triggered, there is no task which practically runs on a cluster. So transformations are like map, filter, join. Lazy operations actions are like count, collect, save, which triggers something on a cluster. So some sample transformations like map, filter, sample, union, group by key, reduce by key, join, cache, all these things will not do anything for you. Till the time you do not trigger an action, something like reduce, count, save, lookup keys kind of thing. So these will return some data to the driver, or they might store the data onto the data nodes based on the action type. So like collect will return the data onto the driver. Collect is very costly operation. Do not try it up with big data, because that will try to collect all the data and will send it to your driver program. Count will do the count on the corresponding partitions and will return the output to the driver program. Save will save the data onto HDFS kind of thing. So before we go into the real Scala program, let's try to understand the Lambda. Anyone understand what is Lambda or Lambda functions? Because we'll be writing everything in Lambda and that will sound Greek to everyone.
Yeah, so the Lambda is the architecture which would support lightning speed online writing as well as the batch process. So the architecture by itself has fulfilled the needs.
Oh, I'm talking about Lambda functions.
Oh no, no clear.
Okay. So these are also known as anonymous functions. So this is a Lambda function. So I say rdd.flatmap line to line dot split this, and my line is splitted and I've got the words out of the line. So what happens at the back end is, let's try to understand what is happening is, so you try to write a function inline and this reduces your lot of code. So this is how we practically write up in the Java world. Let's say this is a function, add1 is a function which adds one item, or which basically adds one to your item. So if I have list which has two items in it, I can call this add1 function on all the elements of list by writing a for loop, item int list add1 item, and this will return me practically 2,3 rather than 1,2 as an input, right? So this is how we practically write till now in Java or any other languages which you will be using up if you have not used Lambda functions. So right till now fine. Okay.
Yep, perfect.
Now
What's the use of the function?
I'm coming to that part. Just wait for 2-3 minutes. So this could be rewritten like this. So the same thing could be rewritten like this. So this code could be rewritten like this. And what we did over here is, let me explain you. So this thing could be rewritten like this. So rather than writing that function and writing a for loop and doing all that thing, writing that 5-10 lines program, I have written it in a single line. Int list map int item plus 1, and that is done for me. So what is happening over here is this is the input to the function. This is your function, and how it need to be implemented, that based on what I'm calling up on map or anything. So that will do up for you. And so this is a for loop where map says it need to be implemented for each and every element in the list. So this function will be applied to each and every element in the list. So int list map item to item plus 1 will return me the same thing 2, 3 what has been written by this program. Make sense?
Basically, right now we are dealing with that looping thing, right? Miraj, and
Yeah.
I don't know, when we were comparing in the scenarios where we have to actually write a map reduce, I think we mentioned about that, looping for any of the for loops. I think we will need map reduce, but as part of Spark we can do this, right?
No, don't confuse this map with map reduce. This is just a function map. I could have written some other function also over here.
Oh, okay.
Let's say I call it for each or for each value or anything. So this is just a function.
Okay, cool.
So the lambda function is so there are a lot of languages which support lambda functions like your Python, Scala, Java, or also came up with in version 8 I think, or version 7. I'm not sure. Java also came with lambda functions. So this is you're calling your function inline. So this whole code is written like this over here. This could have been anything. So whether it be a for loop or anything, that will depend on this function, on what I'm calling up.
Okay, got it.
So let's try to play with some of the things and we'll see it. So over here I'll be using the lambda functions also and all those things. So let's try to play with it and try to do something before we proceed. So you can also try it up on your laptops. We are not running anything great, and these all will be single lines. So you can just try to read any file from your HDFS. Just give the path of the file, and so I'll just ping this command to you. You can also try and play with me right now if you want. So here I am reading a file from my HDFS, and this is an RDD which has been created on the file. So this RDD would have a lot of partitions. These partitions are your data blocks which are lying on the data nodes. So see, it returned me an RDD of type string. So if I say input RDD dot for बड़ा अच्छा नहीं होता. If you type tab on your laptop, that will show you all the functions which are available with the corresponding variable. So for each, let's say I want to just search, let's first print the file, println. So this will, so again this will call the println function for each and every line of input RDD. So println is a function which I am giving up to this for each. So for each line of input RDD, println function will be called up. And for each is an action, it's not a transformation. So this will happen there only right now. So it will print the file for me. So the file is printed over here. So let's try to pick some words from the file. Let's say Delhi. So input RDD. No? So input RDD dot filter x dot मेरे को यार वो I'm not habitual of writing onto the console, so I'm not sure contain is the correct function or not. X dot uh, let me open the Eclipse. I'm also not sure if it's the contain is the correct function or not. So I'll just check what is the exact function name. So contains or equals, we can just try equals. Let's try equals. EQUA equals to string पे लगा सकते हैं. Contains का exact syntax मुझे नहीं पता. So this returned me another RDD, and if I have not assigned it to a variable. Let's say where filtered. So I've got another RDD filtered. If I say filtered dot print, filter dot for each println. So this is again an action. So I've got only one row because I filtered only that thing. So यहाँ पे मैंने क्या कहा? I've just said filter, and this is again a lambda. So for each x, that is for each line, apply line dot equals. People with me? ट्राई करना किसी को?
I can't try, though curious, Scala का कोड कहाँ से मिलेगा? Installation.
Scala का installation नहीं चाहिए ना. Yesterday we installed this thing, Spark, on the laptops.
Okay.
You have to just download the Spark .tar file and just unzip it. That's all what was required. Even if the error was coming, you can ignore it right now because we are not dealing with Hive context.
Hiraj, I got
Yeah.
one question. Can I share the screen?
You want to share the screen? Okay. Give me a minute. Make presenter. Yes. Yeah.
Yeah. If suppose, can you see my screen?
Yeah. I can see.
Yeah. This particular one contains it's a pretty huge file which contains almost like this many number of blocks.
Okay.
This one block size is this one, and initially it is displayed from on this particular one, and in this I can see only this much content. And what about the other blocks, how it is displayed there? Because I read the same file over here, and input rdd dot for each print ln, and it has printed. And what is the stage of 0, 0 plus 0 has 2, and it has displayed up to here. And what about the other blocks?
Sorry. Can you please repeat? Sorry. Can you please repeat?
If you see this, this is a block size of 460 bytes, in which it is displayed this up to 765. If suppose this is a very huge file, and everything will be displayed over here, or it will be displayed in the type of blocks or something like that, like how this particular one is displayed.
What you did and what you are doing?
I'm just read the particular
For each
file,
print ln.
and
So that will print everything. So this data will be given to your driver and driver will print it for you.
okay, you mean to say whatever the content is over here, it has printed? Because if you see here, it is last ending with these particular ones, but here I can see it has stopped somewhere in middle.
वो तो डिपेंड करा होगा ना पार्टीशंस कैसे बने आपके.
Okay, okay. Because I see, because here there are more than like a lot of files, lot of this particular words.
Did you did some filtering or something? No.
No, I just read this particular file and input for each.
For each print
That's
ln.
it.
That's all. So
Yeah.
that will print everything.
Okay.
Lumala.
Let me complete this.
Lumala.
I'll try to
So
complete
Lumala is
this.
there. You can just say count.
No.
Not count. Just do go over there. Input RDD. Input. No, just print ln na. Just type print ln. Print ln. इनपुट आरडीडी काउंट का ब्रैकेट के अंदर इनपुट आरडीडी डॉट काउंट डॉट काउंट.
That's it. 100.
1 minute,
But
I missed you.
yeah,
Got it? 100 over here.
let me see.
Is this the only file or there are other blocks also? I don't know.
Yeah, this is the only file which I have.
So just go to putty. Open another putty. अरे इतना नहीं मेहनत करनी. Open another putty. एक और पुट्टी खोलो. ऊपर राइट क्लिक करके पुट्टी. ऊपर राइट क्लिक करके वहीं से ऊपर राइट क्लिक करो ना. इसी के ऊपर राइट क्लिक.
Okay, okay. New
न्यू
section.
सेक्शन.
Okay.
Login. And type hadoop fs minus cat, your file name, and pipe wc minus l.
Cat. This is the file. Pipe.
अरे क्या लिखा है एक बार दोबारा दिखाना मैंने देखा नहीं. And
Hadoop FS minus
Hadoop FS minus cat नहीं Hadoop FS minus cat पाइप बाद में आएगा, पहले क्या फाइल तो गेट करो, जिस पाइप
okay,
हटाओ, cat के बाद का पाइप हटाओ.
okay.
Yeah, go to the end of the line, go to the end of the line.
Sorry.
And space,
Yeah.
space, pipe,
Okay.
pipe is WC,
Okay.
WC space minus L. Enter.
Okay. Okay. Here it is 99.
99. And there it was 100.
100.
ऊपर कोई blank line भी है क्या?
शायद पता नहीं.
ऊपर या नीचे कुछ blank line भी होगी.
Okay. 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 देखता हूँ एक बार. Okay. Thank you. Suppose if it is like a very big file, everything will be displayed in the console, or will it be like a blocks or something like that?
It will be displayed on the console. So this will be given. This will be again वो executors आपका data driver को भेजेंगे. Driver will display it for you.
Okay. 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 Thank you.
So let's say हम क्या कर रहे थे? हाँ, input let's say a where a is equals to input rdd dot filter x and x dot cuntins contains Dali. So again a lambda function, and now a dot for each so only the lines which contain Delhi. And if I say a dot count 4, how it came very fast? Because this data was cached for you. So although I have not given cache, but वो उसके cache में पड़ा हुआ था, इसलिए इसने जल्दी से पढ़ के बता दिया मुझे. So practically what you do is you do some filtering or those kind of operation which you want to do, and then you cache the data and then you play with the data. So again the thing is should we use Spark? So the thing is if you have to do a lot of operations on your data, कई सारी चीजें करनी है, and that makes it in such a scenario it will make sense for you to read the data once, cache it, and then do a lot of operations. But you have to do it only once. Then you might be thinking कि मैं MapReduce में चला लूँ या Spark में चलाना है. Well, you have to just read it once, तो IO तो हो गई आपका. So it won't give you those kind of significantly great optimizations or significantly faster as compared to MapReduce. You have to just read once, although it should give up because it's faster, it's try to optimize the things internally. But in such a scenario, you have to think of whether you want to use a MapReduce or Spark. So another things which I'm doing over here is filter I just shown you, count we just printed up. So let's try to run the word count program. So what I did over here is single line word count is done for me. Just one line word count is done for me. Oh sorry, errors are due to था ही नहीं मेरे पास. So मैंने क्या बनाया था? Input RDD बनाया था. input RDD. So what it did over is input RDD dot flat map. Flat map is a function which flattens up your thing. So हर line के लिए line split हो जाएगी space पे and I'll get each word as an individual line. Then what I'm saying is dot map. हर word के लिए word comma one print करो. That it will create a key value pair RDD, which is and the key over there is a word and the value of that word value of that key is 1. And then I'm saying reduce by key, that is reduce everything in the previous RDD with the key. And what function is applied on the values is for each value of the two similar keys, sum the values. Oh, sorry, yeah, I pressed the wrong key. So it will return me word count errors, and I can just say word count errors dot println. So the same word count program is done in one line. So what we did in these functions, I'll explain you. Map function kya hai, flat map kya hai, reduce by key kya hai. But this is all what I did it with the help of lambda and these functions. So let's say I write the same file and yeah, go ahead.
Niraj, and these functions are available in the Eclipse, right? Once we get the plugin.
Well, yesterday I forgot to share that thing with you. Actually, I was too busy yesterday. So मुझे अपने flat का position लेने जाना था, so I went to Noida and that has spoiled up my whole day to get the things done over there. So,
And is it possible for you to show once in Eclipse
Acha,
these
so,
functions?
okay. So once, just give me a minute. Let me open Eclipse. Okay. Can you see my screen?
Yeah, now we can see.
Okay. So actually, the problem is the GoToMeeting Apple software is stopped for all the versions less than 10.9, and mine is little older than that. So I'm not able to start the GoToMeeting over there. So I've just shared the screen from my Apple to over here. So yeah, you wanted to run some function. Okay, I'll run it for you. So let's open this guy. Okay, so okay, so let's try to play with this. So I've just read the file, any file, and you can give any path. Let's say given some path. So this would be little slower for you people, I understand. Okay, let's read some temp slash abc dot text. Okay, so I read the file. Now val filtered is equals to abc dot, and as soon as I press dot,
It's pretty slow. Probably I think you need to stop for a while. Yeah. Yeah.
abc
This
dot,
shows all functions.
yeah, all functions. So let's say abc dot filter, and as soon as I press filter. So if you are seeing a delay in visualizing my screen right now, you can open a browser on your laptops with what I am opening up in my over here. You can open this browser. That will be a little bit faster for you. Right now I'm showing what's running on my Apple system. Unfortunately, this GoToMeetings does not support the older version. They've recently disabled. Till last week that was running up. So they've, I think, disabled it last week only. So that's the reason I'm not started GoToMeeting over there. So if you're seeing a significant lag, you can open this URL also, which I have just now highlighted, and that will show my screen. So as soon as I press filter पे enter मारूंगा मैं, ये अपने आप लिख देगा. And X is a dummy variable name. I can give it any damn variable name. So let's say I want to give it error. And then what I want to do with the error, let's say, okay, error dot length. I just wanted to see the length of the error which are greater than, let's say, 20. So line size which are greater than 20 would be filtered up. Okay, so this is nothing but the Scala. Scala plugin which I am running up over here. You can see over here Scala plugin instead of Java J2 Scala plugin, and that has everything for you. And how to compile it? You can compile it with the help of SBT. So you have to create an SBT file. I'll share you the whole Spark project, one of the project that contains an SBT file. So similar to POM, there's something called SBT, and you have to just tell. So similar to POM, you have to also tell key kaun se dependencies and all those things into SBT, and you can just run the SBT commands to compile them. I'll share some of the useful commands which I have written up. दो तीन जो आपको काम आएंगे, those I've written up. I'll just share with you people. So you can see sbt.assembly package dependencies. So this will create a jar with all the dependencies for you. This will just package your code. SBT Eclipse will create an Eclipse project for you if you are not able to see, if you're getting compilation errors while running it in an Eclipse. And with source code true will get all the source code also for you. And this is how you create your SBT package, and then once created SBT package, you can submit it to Eclipse without rather than running on that console shell. So that console shell you will be using up for testing purpose and doing a number of things, but practically you will be submitting your jobs to the Spark Summit rather than running out on the console Spark shell. Guys, over here I'm speaking a lot of things. मैं काफी कुछ short में करके बता रहा हूँ आप लोगों को, because this is just the basics part which I'm covering up. So exactly there are 3 modes how to run the Spark, and there are a lot of things which are there up, but I'm skipping a lot of things because Spark itself is a big session. So I'll tell you all these things, flat map जो हमने करा अभी and all those things जो अभी हमने करा, all these things I'll tell you in next few slides. So what we did is we use map also, we use filter also. So when you see I type a map and filter, there's practically nothing happened till I did not trigger an action. So all these things are transformations. So what exactly the map function is? Map will try to map all the things, all the values in your RDD to the corresponding function. Filter will try to apply this filter function to all your values in the RDD. Union will union with your another data set. Intersection will intersect with your another data set. Distinct will produce distinct values as an costly operation. Join with another data set is similar to your inner joins kind of thing, which you can do. So I'll show you all examples of all these things. So let's say I called map on my this RDD, which contains three things: A, B, C, D, E, F, G. इसके ऊपर मैंने कहा rdd.map and this tokenize as a function. So tokenize functions is this thing. So tokenize functions, what tokenize function do is, so this is a function which I have created up for me. So tokenize function क्या कर रहा है? Whatsoever value is given to it, it returns a list of that value. So if I give him a comma b, a space b, it returns me list which contains two variables a and b. So when I call map tokenize, it returned me one list AB, another list CD, and third list E, F. So this function is applied on each and every value of this RDD. So map is a function which applies the corresponding function which has been passed to the map function to all your values in the RDD. And just now we have used flat map also. So flat map will try to flatten up the things. So this will produce something like this. It would be extremely complex for you guys to digest all these things, I understand, but once you understand these things, it will be extremely easy for you to play with them. But you can just keep on asking questions that will help you to understand the things. So let's try to apply some other functions. So let's say I applied, so this is one RDD, this is another RDD. Let's try to apply some functions on these RDDs. So let's say I say RDD1.distinct. So it will produce me the distinct values. So it will produce A, B, C, D. Two A's are removed. RDD1.union RDD2. So it will produce a union output. RDD1.intersection RDD2. So intersection A and C common है, AC. RDD1.subtract RDD2. So subtract करा तो A गायब हो गया, C गायब हो गया, B and D बचा, B and D is there. Any queries? Not going good? Actions. So till now we were looking at transformations. They will not trigger any action for you till you do not do some action. So reduce is an action. So reduce will apply this reduce function on your input RDD for each and every value. So if you remember over here we applied reduce. So here we applied reduce by key. So similarly there is a reduce function. I'll show you an example. So this will reduce the values. Oh, sorry. Take n will just take an sample of n values. Collect will collect everything and send it to your driver. Do not try it on big data sets. Count will do the count of the RDD. Save as text file or save as sequence file or any other thing will save your data onto your SDFS. So let's say this is one RDD 1, 2, 1, 2, 3, 3. And if I say RDD.collect, this will collect the things and will send the RDD to your driver. RDD.count will produce me 4 and this will just count the thing. So these are all the actions. RD.count by value. This will try to count all your values. So 1 is 1, 2 is 2 is, यहाँ पे mistake है. There is a mistake in this slide. So this will produce 1. 2 is 1 and 3 is twice. 2 is once and 3 is twice. RD dot take 2, this will just take sample of 2 values from your input RDD. RD dot top 2 will ensure you take top values based on the sorting order. RD dot take ordered, and my on ordering, I could have defined any ordering over here. RD dot reduce. So here what I'm saying is for each x comma y, that is reduce will take 2 inputs and will try to reduce them. So for each x comma y, so this will keep on taking values in pairs. So first 1 and 2 will be passed to it. So for 1 and 2, it will return 1 plus 2, that is 3, and then 3, and this 3 will be passed to this, and it will return 6, and then 6, and then this 3 will be passed to it. It will return 9 as an output. So if I say over here, मेरा कुछ RDD था ना, A था क्या? हाँ, A. So A dot reduce और x के लिए let's say x, sorry, और x comma y के लिए x plus y. So can anyone tell me what would be the output? This is A. I say A dot reduce x comma y के लिए x plus y. Oh, I have not defined it to any other variable. Val BC is equals to this. BC dot for each RINTLN, and the output is Are you people there with me? That I just printed sample. I have not printed everything. There are complex functions like aggregate functions. Am I audible?
Yes, sir.
Yeah, you are.
Okay. Okay. So they are complex functions like aggregate functions. I am going fast. I'm just giving a glimpse of what is there in the Spark. I can't cover everything. So I'm just giving you a glimpse of the things. You can try to play with them later on. If you want to play with some of the things right now also, you can try it up and I can help you up if you want to achieve anything. So aggregate functions are practically functions which allow users to apply 2 different reduce functions on the RDD. So first reduce function is applied within each partition to reduce the data within each of the partitions, and then second reduce function is applied to combine the data from different partitions to get it together. So I have told you that your RDD is divided into partitions and you apply your task on the partition. So aggregate is a complex function which is available for you, which will try to apply a first reduce function which you have given to this aggregate operation which is applied to your partitions or each of the partitions, and once your data is merged from partitions, you apply a second reduce function. So let's say I want to figure out average of average of values. So what I did over here is I say input is my file dot aggregate. I am saying it's a key and value pair starting from 0, 0, and I can give any dummy values. I could have given it x, y also. I could have given anything. So let's say I've given over here value acc, value. So what I'm saying is, okay, again one complex thing. So this is a tuple in Scala. So underscore 1 means first value from the tuple, and underscore 2 is means second value from the tuple. So acc dot 1 plus value, that is this value, acc underscore 2 plus 1. So this is your value, this is your count of values. So acc is a tuple of 0, 0, and value is the value which is passed to this function. So acc dot first, that is the value में मैं नई जो value आई है उसको ऐड कर रहा हूँ, और मैं कह रहा हूँ कि एक नई value आ गई है मेरे पास. And once I want to aggregate these things, I will apply another reduce function. So acc1 और acc2 को कैसे ऐड करना है? acc1 plus acc2, this contains the sum of the values and this contains the count of the values. So this is now the sum and this is now the count. And what I said is, so this has been stored into result. So result is a tuple. The first thing contains the values ka sum and second thing contains the count. So I say first thing from the tuple and second from the tuple. So sum divided by count, this gave me an average. So what is happening up is, so everything is done in single line, very, very complex language. But once you start writing it, you can't think of writing in Java. So what I did over here is I said ACC will be type of a tuple which is starting from 0, 0. So first value of the tuple is 0, second value of the tuple is 0. And this aggregate function need to be has two reducers in it. One reducer is applied on each partition and another reducer is applied on each when you are merging your partitions. So I'll just clean this slide. So this is your first reduce function and this is your second reduce function. Okay. Now what I said is ACs is of type tuple, which I've defined over here, and value is each value which has been picked from this input. So 0, 0 of this tuple is applied on this value. Let's say first value is picked as 1, or let's say first value is picked as 2. So 0, 0 and 2. 0, 0 and 2. So what I said is I rate this tuple first value, so that is 0, plus value, that is 2. So this will return me 2, and ACC2, that is 0, plus 1 will return me 1. So this will become 2, 1. And let's say the second value in this tuple is in this input is 3. So now I have 2, 1. So this will become 3, and sorry, this is 2, value is 3, this was 1, 1 plus 1 2, so 3 plus 2 5, 2. So this has been applied to on each and every partition of your input data set. Clear till now?
Yes.
Now second reduce function is applied when you merge the data from different partitions. So from each partition what I am getting is 5, 2 kind of things. So one partition might return 5, 2, another partition might return 6, 8. So not 6, 8 is not possible. 8 things can, or if they were in decimal, let's say 6, 3. Another partition returns, let's say 5, 2. So if I change the color of the pan to green, so these are the values which are written from different partitions. Now this reduce function will be applied on the values written from different partition. Let's say there were 3 partitions. So each of them is kind of a tuple, ACC1 and ACC2. I have given the name to this tuple. ACC1 is the first thing. Another ACC1 is this, and ACC2 is this. So what I'm saying is ACC1 ka first is sum to ACC2 ka first. So 6 plus 5 is 11, and ACC1 ka second thing is summed with ACC2 ka second. So 3 plus 2 is 5. And now 11 comma 5 becomes your ACC1, and ACC2 becomes 5 comma 2. So 5 plus 11 is 16, and 5 plus 2 is 6, 7. So this is an output of this input dot aggregate and all these things, and this becomes your, if I change the color, so the one which I've highlighted in purple becomes your reduce, And on reduce, what I'm saying is reduce underscore 1 divided by reduce underscore 2. So 16 divided by 7 is my average. Make sense, or shall I repeat?
Meena ji, I mean, we got the logic, but ऐसा कौन सा केस में ये एग्रीगेट कॉल होगा यानी
So let's, काफी सारे हो सकते हैं पार्टीशन पे आपको डेटा करना है. So let's say your data is divided on let's say you have very big data sets. Now I want to I was applying this aggregate function on the data which was coming from the Wink movies, and so what was the problem is the events which are getting generated from the app was so each event did not have the whole history of which movie is getting played, what at what play position the movie is, all the context of the movie, and the user history, user age, and everything was not coming up. So first I wanted to divide the data on to, basically I want to sort the data, all the events of a user, and then wanted to apply some functions. So I partitioned my data onto users. So in each partition I'm ensured if I'm playing with user ID X, that is available in the same partition. So I applied aggregate over there on that on the partition, and then once I wanted to get the total statistics over the user, I applied another reduce function. So I applied 2 reduce functions.
तो आपने उस केस में भी एग्रीगेट में इनिशियल वैल्यू 0,0 डाले थे?
नहीं, वो तो मैं बेस्ड ऑन मेरा इनपुट, वो तो बहुत बड़ा जेसन है, तो दैट डिपेंड्स ऑन अदर थिंग्स. दिस इज अ सिंपलिस्टिक व्यू.
ओके, तो ये जो इनपुट है 0,0 वो यानी हम लोग का इनिशियल जो पॉइंट होता है,
स्टार्ट पॉइंट का स्टार्ट है. यू कुड नॉट हैव गिवन इट आल्सो. आई थिंक ये नहीं, शायद कंपलसरी एग्रीगेट के अंदर, इफ आई एम नॉट रॉन्ग.
वो कैसे फिर हम लोग देंगे? अभी आपने जो एग्जांपल दिया कि इसमें ये पर्टिकुलर यूजर आईडी अपने को पता नहीं कि कितनी बार क्या यूज कर रहा है, तो आपने उस केस में फिर जो इनिशियल पॉइंट दिया था वो यानी
वो तो यूजर की रॉ स्टेट, आई विल टेक अ रॉ स्टेट, जो भी एक यूजर की रॉ स्टेट होगी, आई विल टेक दैट एज द इनिशियल पॉइंट.
ओके 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 ओके, तो आपने वो 0,0 में बोला कि अच्छा ये उसका स्टार्ट पॉइंट है.
So if I show you this thing, so I have created a RDD which I am creating right now from Parallelize. I told you there are 2 ways, either read from HDFS or you can use Parallelize. So I have created a RDD from this Parallelize. So this given me an RDD of integer. इसने automatically detect कर लिया सब कुछ integer है क्या है, and that give me an RDD of integer. So I apply the same thing over here जो मैंने अभी दिखाया, and it returned me an RDD of integer comma integer, and 21,6 is an output इसने calculate भी कर लिया on the fly. And if I say this thing, 3.5 is an average.
तो इस केस में अपने को जो एवरेज मिला है वो इसका है क्या कि
1 2 3 4 5 6 का एवरेज 3.5 होगा.
1 हाँ यस यस.
So you can purchase the RDD as we proceeded over here. Sorry, calm your slide. So as we proceeded over here, once we have read a very big file. We filtered the big file on what I wanted, and I persisted this RDD. And then on this RDD, I applied a lot of other functions. So I applied 2 filters on this RDD. So you can persist these RDDs. These RDDs will be available as a cached block for you on the worker nodes, and then you can play with those RDDs. If you cache them, your next operations, further on operations, will be extremely fast. But this caching will only happens once you apply some action on the RDD. So after this count, you can see the real caching happened. Before that, that was not cached. So after I applied this count, this was cached. So you can apply a different type of caching on the data. If the data is not fitted in the memory, by default that will be spilled onto your disk. So you can process or cache the data. So it could be memory only, it could be disk only, it could be memory and disk. And you can also call unprocessed, that will remove the data from the memory or disk where you have processed it. So all those fault operations, fault tolerance and everything is available for you. So if the data is lost, that is practically being recalculated, and it contains the graph how to get it recalculated. So if the data is lost in such a scenario, it will be recalculated also, but your program will not fail. So Spark versus Hadoop MapReduce performance. Spark is normally faster, but with caveats. Spark can process data in memory. Hadoop processes the data back to the disk after map and reduce action. Spark generally outperforms MapReduce, but it often needs a lot of memory to do well. Now you can understand why it needs a lot of memory to do it well. If there are other resources demanding सर्विसेज इट कांट फिट इन मेमोरी स्पार्क डिग्रेड. सो अगर मेमोरी उसको ज्यादा नहीं मिलेगी इट विल डिग्रेड द परफॉर्मेंस. MapReduce easily runs alongside with other services with minor performance impact, but here there will be a very great performance impact on some other services which require your memory. So you have to design your Spark course in such a way that your other applications which are using memory on the data nodes are not get affected. MapReduce is designed for data that does not fit in memory. Spark is easier to program. You have seen कि मैंने कितनी simply एक line के अंदर we have written so complex things which you can think of if you want to write in MapReduce, how complex those would have been. So and MapReduce also you can do those things with the help of Hive and Pig, which make it MapReduce also much simpler. So Spark is still in a developing phase, although there are a lot of things which are happening in the Spark world, but is not as developed as compared to MapReduce. So MapReduce is much mature as compared to Spark. MapReduce doesn't have interactive mode like Spark Shell, which you have seen right now. So that is an advantage of Spark. Staffing, another challenge for managers. So getting developers from MapReduce is easier as compared to Spark because Spark came up after 2010. So again, the experience sources in Spark are not as readily available as compared to MapReduce. So can run and stand. I told you that can run and 3 more standalone Yarn and Mesos. So Yarn and Mesos are cluster managers for Hadoop and AWS. Standalone is the mode which we were running right now, where we will run a Spark shell. Those kind of modes are not available in your Hadoop world. Spark integrates BI tools, while JDBC and ODBC is still a big challenge. Spark can do real-time processing as well as batch processing. That's a good thing. You can write one code once, and same code could be used for batch processing as well as real-time processing. So code will not change. You can just call the same function. You can create functions for the processing. So for implementing Lambda architecture, this is very good as compared to Storm, because in Storm you have to write a separate code for real-time processing. You have to write another code in MapReduce or any other thing for batch processing. But in Spark, you can write code once and you can use both the code in your batch processing as well as real-time processing. So that's an advantage of Spark as compared to Storm. Another advantage of Spark as compared to Storm for real-time processing is Storm says your data is processed at least once. At least once. At the most, it can be 10 times. So if you are doing some, let's say I'm doing count of users who are logged into my website, I can't implement that correctly with Storm, although there are ways to implement it, but in a simplistic way, I can't implement it correctly because my same data could have been processed thrice also. It guarantees process once, but at most it can be anything. So I can't get to count kind of things exactly perfect in Storm. Although there are ways, but not in a simplistic way. But in Spark, I can do that thing, because the data is divided into windows and you apply operation on windows. Then Spark is coming as a bundle of everything. So similar to Java world, guys, what we call that? क्या होता है? Spring. So Spring started up with small things that keeps on bundling a lot of things, and now Spring is so complex. It has everything available as Jar. You can play around with this. Spark भी कुछ उसी scenario में उसी type पे जा रहा है. It's trying to package up everything for you as a single thing. So everything is possible with the help of Spark. Spark Batch, Spark Streaming, then your machine learning coming up over here, graph, everything. They are trying to package everything. So they're trying to make it single stop for all kind of data processing. Failure tolerance, MapReduce relies on hard drives. If the process crashes in the middle, it could be continued where it left, whereas Spark will have to do start the processing from the start. But I told you these RDDs. So the data which is cached up, if that data node goes down, it has the graph how to recompute that RDD. So it will recompute that RDD from the beginning. And how it has that graph? It has that graph by virtue of this thing. So by virtue of this thing. So it contains this driver has all this logic what need to be applied up for the task. So this graph is created by your DAG scheduler, and it knows everything how the graph what was the graph to which computed that RDD. So if that RDD which was cached up has been lost up because of data node failures or similar things, that graph will be recomputed on your data which is stored in HDFS. So it will start from scratch. I told you security is a challenge yet to come. In Spark, there are a lot of things nowadays, Ranger, Kerberos, and Knox. So, but the thing is, in MapReduce, there's a MapReduce chain is a big challenge. Over here, you just start up the things. It will do all the task optimization for you, will create the task boundaries for you, and will try to optimally run your code. So it speed up the computations for you as compared to MapReduce. Any questions? So I'll share some problem statement with you people, which will just require some of the functions which I have talked in the PPT, like map or reduce or take or top or count, filter kind of things. The simple functions, not complex key value function, all those things. Just try to play with them and you will get a little feel about the system. And also share the Scala Eclipse version so that you can run up the things. And I'll also explain in the next class how to create an SBD project, and you can open it in the Eclipse, as well as how to compile the things or run it with the help of jar once you create a jar with the help of SBD. And then I'll also share a document how to install Kafka if you want to play with Kafka, or I'll start a Kafka version on my laptop and will show you um, mm, connecting Spark with Kafka, and we'll try to run some basic code on Kafka to do some counting of the things, or some basic thing. And I'll also share a project with you people which you can try up, and once you are done with the project we can have another session to discuss that project. But it's very rare people come back with me as a solution of the project. So it's up to you how much time you want to spend up, and if you want to do that project, definitely I will love to see the output of the project, and then we can have a discussion how to on the solution which you have implemented for that project. So guys, any questions? Anything? So for tomorrow, rather than GoToMeeting, I'll create another link so that I can share directly from my Apple laptop. There it will be much easier for me to tell you of the things. So I'll probably share another link with the people. And if any link is not shared, you can use this link. If I'm sharing any other link, just try to open that link rather than this GoToMeeting link. So I've gone very fast on the Spark part. It was just a basic part where I was just wanted to show you what exactly or what all things are available in this world. But this requires extensive class of extensive session of everything to cover up in Spark. Okay then, we can wind up for now, and we'll meet tomorrow. And tomorrow we'll wind up everything. And if you have any questions, you can definitely come back to me anytime. Also, and if you are done with the project, then I'll love to see that output. Okay then, thanks for your time, and good night. It was too silence today.
See ya. Thank you, everyone.
Thank you. Have a good night.
Thank you.
Thanks, Miraj.
Thank you.
Thanks, Miraj.